Good morning. This is Melody Rondo, and we're going to continue in our notes on properties for discovering properties of exponents. If this is not where your class is, feel free to fast forward, but we're going to get started here with zero powers. So first, you can see we're just picking up like we did yesterday. We're going to be expanding out. You can see the first one is done for us. So it has 2 to the fourth. So we see 2 times 2 times 2 times 2. There's 4 of them across the numerator, the top of the fraction, and across the denominator, the bottom of the fraction. And anytime we have a number divided by itself, we talked about this yesterday, that equals 1. So 2 divided by 2 is 1. 2 divided by 2 is 1, 2 divided by 2 is 1, 2 divided by 2 is 1. So we have 1 times 1 times 1 times 1, which gives us an overall answer of 1 at the end. So that is how we work through this. You can see when we rewrite that using exponents, that gives us 2 to the 4 minus 4. And that part right there comes from a previous topic in this packet where we talked about when we are dividing with like bases, we subtract those exponents. So I'm going to go ahead and work on the next one. It says I'm going to multiply 5 6 times. So the number 5 6 times in the numerator, the top of the fraction, and 6 times in the denominator or the bottom of the fraction. And so when I do that, I'm going to switch colors here so we can see that canceling out. 5 divided by 5 is 1, 5 divided by 5 is 1, and so on and so forth all the way through. And so our end answer then must be 1. But the way we write that with exponents is we say 5 to the 6 minus 6, which is 5 to the 0. All right, on to the next one. Same thing. Negative 8, we're going to write that 3 times in the numerator or the top of the fraction, and 3 times in the bottom or the denominator. And again, I'm going to cancel out. So negative 8 divided by negative 8 is 1, and so on and so forth. And so my end answer I end up with is 1. And the way that I represent that with exponents, I get negative 8 to the 3 minus 3, which is negative 8 to the 0 power. The last one, 9 squared. So I'm going to do 9 times 9 and 9 times 9, numerator and denominator. And again, cancel. 9 divided by 9 is 1. 9 divided by 9 is 1. And that gives me an overall answer of 1. And I show this with exponents by saying 9 to the 2 minus 2, which is 9 to the 0. So our general rule for 0 powers, x to the 0 equals 1. And then it asks us, does this rule work for 0 to the 0? So here's the situation. If I do this with zeros, I can pick any number of zeros. Here's what I run into. It looks like it should cancel out in that same way because I have 0 over 0, 0 over 0, 0 over 0. However, we have this rule in math that we are not allowed to divide by 0. So this is actually considered undefined. We can't divide by 0. In fact, I'll write that. We can't divide by 0. So just having 0 in the denominator in that way is not allowed. So it doesn't work for 0. That's the only number it doesn't work for. Anything else I put in there for that x or any other number to the 0 power will equal 1. All right, on to our last one, the negative powers. This one is the most tricky. So we're going to be using, again, that rule when we divide like bases, we subtract the exponents. We see that canceling business again. I end up with a base 2. So 2 to the 2 minus 5, which gives me negative 3. So that's how I represent it with exponents. But then to write it without that negative exponent, I end up with 1 over 2 cubed. And that comes from here because my 3 2's that are left are in the denominator. So here's what a negative exponent means. First of all, what it does not mean. A negative exponent, so if I say like 3 to the negative 1, that is not the same as saying negative 3. That is not what negative exponents mean. What a negative exponent means essentially is that this is how I talk about it anyways. Essentially, it means a reciprocal situation. It's basically that this poor little 2, let me rewrite this a little better here. So to go from the exponent to the fraction version, this poor little 2 to the -3, the -3 is unhappy. We call them the unhappy exponents. And so that negative is really telling you that this 2 is in the wrong location within a fraction. So here, to make that -3 a happy or positive exponent, we actually move the base and the exponent to the denominator. So we're going to practice this. Here goes. With the next one, I have 4 times 4 times 4 times 4. There are 4 of them. And then in the denominator, oh dear heavens, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I think I got 10 there. 1, 2, 3, 4, 5, 6, yep, 10. Okay, so that's my whole crazy denominator. And of course, I'm going to cancel them out. So here we go. Cancel, 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 cancel. So I am left with 1, 2, 3, 4, 5, 6. I have 4 6s and they are in the denominator. So I would write this as a fraction. I would say 1 over 4 to the 6th. When I write it with exponents, I would say 4 to the 4 minus 10, which gives me 4 to the -6. And again, we see, I'm going to rewrite that. Hold on one second. So we see this as 4 to the -6. Currently, this would just, if I wrote it as currently as a fraction, this would just be over 1. But again, because I see that negative exponent, that's my hint that this 4 does not belong in the numerator, but actually belongs in the denominator. All right, so let's try the next one. We have -9, -9, and then square, oh, not squared. I wrote it twice. That is the squared. Sorry, whoopsie. Okay, so there's 2 of them. And then in the denominator, we have -9, -9. We have 7 of these. See if I can fit 7 down here. It's not looking good. Let me try that again. 7 -9s in the denominator. You guys can feel free to pause while I catch this up or fast forward. It's not very exciting, but I'm going to get 7 of these -9s. That's 6. 1 more. Yay, 7. Okay. And then I need 2 in the top. Awesome. And then when we cancel them out, cancel, cancel, and I am left with, so here I'm going to jump right to it. I have my base is -9. My exponents were 2 minus 7, which means I should have 5 left over in the denominator. And so that negative that I'm going to have here is my way of saying, hey, this is not the numerator, that those 9s actually belong in the denominator. And it can be vice versa too, and I'll show you that in just a moment. So this would be, right now, this would be over 1. But again, that negative exponent's unhappy. It doesn't like being in the numerator. It's our way of saying, hey, that base and exponent really belong in the denominator of the fraction. All right, the last one here. This one I have lots of A's and B's. Here we go. 6 A's and 5 B's. 1, 2, 3, 4, 5 in the numerator. And then I have 9 A's and 12 B's. I can't believe I fit those. Okay. All the way across. Fantastic. I'm actually going to move some of my B's in the numerator so that they can cancel a little bit easier. So let's move these over. We have 1, 2, 3, 4, 5. All right, ready to cancel them out, because remember, we can only cancel for like bases or the same number. A over A is 1, A over A is 1, and so forth. So I can only cancel A's with A's and B's with B's. And so then what I'm left with is, basically I'm doing A to the 6 minus 9 and B to the 5 minus 12, which gives me a to the negative 3, b to the negative 7. Awesome. And then that, again, those unhappy exponents, because they're negative, it means they really belong in the denominator of a fraction. So this really should be a to the third and b to the seventh in the denominator. So essentially, once we move their location, we change the sign of the exponent. So I said I would show us one where it goes the other way. So if I had something like this, where I said like 3x to the negative 4 over y. Okay, for example, the 3 has its own exponent of 1. Any base has an exponent. If it's not written, it's always a 1. So 3 has a 1 and y has a 1. Those are positive exponents, which means the 3 and the y are perfectly happy where they are right now. But the x to the negative 4 is unhappy. It's got a negative exponent, which means it really belongs in the opposite location. It's currently in the numerator, so I'm going to move it to the denominator, and now my exponent is positive. So that would be the answer, 3 over x to the fourth y. So it's really important to keep track of negative and positive exponents. And again, if any base, meaning any number or variable, doesn't have an exponent, we're going to write it with a 1, exponent of 1. All right, so describe the pattern in the table. I'm going to say that negative exponents mean reciprocal. That's the fancy math word, which is opposite fraction location. Ooh, sorry, got crazy there. I don't know what happened there. Location. There we go. Opposite fraction location. And then for part B, write an algebraic rule. This would be basically currently the x to the negative n, if I make it a fraction, is over 1. That means my negative n for the exponent is in the numerator. It's unhappy there, so I'm going to move it to the denominator. So it would be x to the n in the denominator, like so. And we just put a 1 in the top to hold that fraction place. The last one, how would you simplify 1 over 7 to the negative 3? Well, this one, because it's in the denominator and it's unhappy, we would actually move it to the numerator to make it happy and then put it over 1 to show that fraction. So there you go. That finishes our notes. You guys have a practice activity, and I will see you later.